Now we are going to start with the subtopic of nitric acid, that is the nitrates. So as you all know that nitrate is something which carries a radical nitrate, and what is that? It is NO3 negative, right? We can have metal nitrates, right? It is present in the nitric acid. So likewise it is present in many compounds. So first of all our concern is that how we are going to prepare the nitrates. So we can actually prepare the nitrate by reacting metal with HNO3, metal or any metal compound with HNO3, or compounds like metal hydroxide, metal carbonate, or this thing. So they can be actually used. So for example, I have reaction of metal with HNO3. So this is my metal, let's say sodium. I am going to react it with HNO3. So obviously this has a positive valency, positive and negative. This positive part is going to attack this and we will get NO3 plus H2O, not H2 but H2O, because we know that the HNO3 is a strong oxidizing agent. So this is what again we can get by reacting it with metal compounds like metal hydroxide. So this I have a metal hydroxide. I am going to react with HNO3. I am just writing a valency in order to make you more well versed with the reaction. So again I am going to get NaNO3 and along with that I get H2O. Likewise, I can have for this thing the metal carbonate as well. Suppose this is my metal carbonate. Again, I am going to react with HNO3. I am going to put the valencies. Right. So this positive again is going to react this. We get NaNO3 and respective oxides, that is H2O and CO2. So likewise, we can prepare many metal nitrates, just changing the metal and just reacting them with the HNO3. And if we talk about the physical properties now, so physical properties, they are all nitrates are actually crystalline solids. They are crystalline solids, that means they have a strong bonding. Second is that they all decompose on heating, and we are going to take up this property as a main property, and I am just going to show you that how they decompose actually. But for this moment, just keep in mind that they actually decompose on heating. They are not so stable, right? So third is that we can prepare the HNO3 back by reacting the metal nitrate, any metal nitrate with sulfuric acid. So when we do that, this K is going to react with SO4 and we get potassium bisulfate, or somehow we can also get the potassium sulfate also, and along with that we get our nitric acid. And they are actually the metal nitrates are soluble in water. And one more thing is striking in my mind, that if we are talking about the color, so you should know that mostly metal nitrates are white in color, except like copper nitrate is blue in color, the ferrous nitrate has a dirty green color, and the ferric nitrate has a reddish brown color. I will repeat, copper nitrate has a blue color, the ferrous Fe2 positive one I am talking about, ferrous nitrate has a light green color, or you can say a dirty green color also, and the ferric nitrate possess actually the reddish brown color. So that means generally all metal nitrates are colorless except these copper, ferrous and ferric nitrate. Now as I told you that these all metal nitrates actually decompose on heating, so I am just going to show you that how they decompose and what are the products we get as a result. So we are going to heat the nitrates again, it's clear. So the first is that then when we heat up sodium and potassium nitrate, what do we get? So I have a potassium nitrate, I am just heating it because I have to decompose on heating, right? So I need to put a delta sign which will indicate that we are heating, and on heating it is going to under decomposition. So we get Na2O, H2O and NO2. So it gets decomposed into oxide, water and NO2. Likewise, when we decompose KNO3, it again decomposes into potassium oxide, NO2 and water. So likewise, that means we get a nitrogen oxide, we get a water and we get a metal oxide also. Now, if we talk about heavy metal nitrates like copper, zinc, I am talking about all heavy metals except the silver and the mercury one. So if we heat it, what do we get? Obviously, we will get a metal oxide and we will get NO2 plus water, right. This copper oxide, you know that is black in color. So the color of this is actually black. When we talk about zinc, so it forms again zinc oxide NO2 and water. And the color of zinc is why actually, like when it is formed, it is hot, so it's yellow in color, but with time when its temperature goes down, it cools up actually, color again becomes white. So likewise, that means you go this thing, the nitrate undergo decomposition, that is the copper, zinc. Likewise, you can do it for the magnesium, calcium, like that. Third, we have, as I told you, that the silver and mercury being heavy, but they undergo decomposition somehow in a different manner. So here I have AgNO3. So I am just going to decompose it. So when I am going to decompose it, I get Ag, I get NO2, and along with that I get O2. And likewise, if I do it for mercury nitrate, so we get mercurous oxide, NO2 plus O2. This is actually this is actually a silver mirror. This will form a silver mirror. So the difference between two is that here we get to see, sorry, it's not H2O, because we don't have any H here. So we get only the CuO and the NO2. But here what do we get, that when we heat it actually we get the oxygen molecule along with that, and the oxygen with NO2 is something called as silver mirror. Likewise, if we decompose ammonium nitrate, what do we get? We get the, we get N2O plus water, and you know that what is this N2O? This is nitrous oxide, which is commonly called as laughing gas. It is actually called as laughing gas. So this is actually the effect of heat on the different metal nitrates. You need to know that sodium and potassium is behaving in a different manner, and likewise heavy metal nitrates are behaving in a different manner. Nitrates of Ag and mercury again behaving in a different manner, and likewise ammonium nitrate is behaving in a different manner. Here like we decompose NaNO3, I wrote here again, it's not here, it's not included this H2O. We only get the metal oxide and the respective nitrogen oxide, which is NO2. So likewise, you will be doing for different nitrates, for silver mercury, for ammonium nitrate. So likewise, you have to do that. So this is all about our nitrates. Now we will be taking up the test actually, which will where we will study that how we can detect the nitric acid and the nitrates. So just look at the board carefully.